All right, so in this one we're going to go through session 3 of the exam revision day, and session 3 is the multiple choice, 9 questions. I'd expect you to get that done in about, come exam time, 7, 8, 9 minutes, because for starters, this one here, if you put into your calculator solve for that, and instead of that equation equaling 1 equaling 0, comma y, then your CAS calculator will solve that for you instantly. Now, as it turns out, I've done that in my CAS calculator, and you have to, the CAS calculator is not going to be in that format, but then you have a look at which one it suits, and I got an answer of C. Is that right? C. Okay, not going to spend too much time on that. Oh, once again, we went through this sort of stuff yesterday, but if I sketch the graph of x minus 4x plus 2, that's going to give me an intercept of 4 and negative 2, which means that, and forget about that, that means that that's going to be asymptotes there, because clearly that cannot equal 0. So instantly what I did is that ruled out x equals, it ruled out A, B and C. So instantly, within 15-20 seconds, you should have ruled those out. Then what I've done is I've just said, well, the asymptotes are, the turning point's going to be halfway between those asymptotes, and then I've subbed in that point. Subbing in x equals 1 gives me a value of that for the turning point. So you could do that pretty quickly. Now this question here, a lot of students come the end of the year ask me about slope fields because we don't really practice them. Guaranteed you every year there's a multiple choice question on this, and a lot of the time that's about it. But there can be some in some exam 2s, so exam 2 extended response, where you're actually asked to sketch a solution. Now the easiest way to do this, in my opinion, is first of all look at, does it depend with x and y, and because they all have x and y in it, that's not going to help us, but just be wary of that. The second thing is I'm basically going to look at the quadrants. So in the first quadrant, the gradients are all negative. We've got negative gradients. Now if you think about it, if we've got negative gradients but we've got positive values of x and y, then how could those possibly be negative? So therefore, I can rule out A, B and E instantly by looking at the gradients in the first quadrant. Then I decide, okay, what can I do in terms of working out whether it's C or D? Well, if you pick a point, say x equals 2, y equals 1, then you can see there at x equals 2, y equals 1, what does the gradient look like it is? Roughly 1 or negative 1. So therefore the answer must be C. Okay, because otherwise you would have a gradient of like negative a quarter or something, and that clearly is not negative a quarter, is it? All right, we're going to continue. Now this one, you could start going to throw your numbers in the calculator and doing all these in the calculator. What a waste of time. The first thing I would say is that it says that there's a semi-axis length of 3. Semi-axis length of 3 means we're looking for an x minus 3 squared. Okay, and it says, sorry, no, that's fine. A centre of, so we're looking for the centre of 1, which is looking for that, and we're looking at a semi-axis length of 3. So we're looking for over 3 squared or something, isn't it? 3 squared. So instantly, what I look at is I look at A and I go, that's baloney, and then I look at B and I go, well, how could I possibly get that? That's baloney. And x plus 1, if I add that one to that side, so instantly I've ruled out A, B and C. Now in actual fact, as it turns out, I've actually also can rule out this, because that sign x minus 1, that's just not going to work. So just by looking at them instantly, I can just go that it's E. Because think about it. So now I'm looking at that, and then let's quickly transform that into, so that's x minus 1 over 3 is equal to cos t. And then the other one is y minus 3 over 2 is equal to sine t. Now if I square both of them, that's going to give me x minus 1 all squared over 9 plus y minus 3 all squared over 4 is equal to sine squared plus cos squared, which is equal to 1. There's your ellipse, has a centre of 1, 3, has a semi-major axis and a major axis of 3 and 2. Yeah? So you start wasting your time on calculator there. It's not necessary. I don't think, personally. Did anyone here use a calculator for that? No? Okay, good. All right, now this one. Think about the graph of tan. The graph of tan has a domain of, well, we have to restrict the domain for it to have an inverse. And we have to restrict the domain to negative pi on 2 to pi on 2. So the domain of the range of the inverse, inverse tan of x, the range of that is equal to minus pi on 2 to pi on 2. That's straight off your formula sheet. Now think about it. What do we apply? We apply we multiply every y coordinate, if you like, by b. So therefore it's minus pi b on 2 to pi b on 2. And then what are we doing? We're adding a to everything. So if I add a to minus pi b on 2, and therefore the answer must be D. Once again, think about it. If you know your stuff, if you know the range of the inverse tan function, and you can apply those transformations, that's a 30-second problem. And then you can start focusing your energy on something else. We're going to continue. What does a Coset graph look like? Well, for starters, a Coset graph actually looks something like this. Okay, and a Coset graph looks something like this. So clearly this shape has been moved across to the left or the right. But what I'm looking for is the period. The period of a cosine graph, or of a Coset graph, is the same as a sine graph. So therefore, the period is equal to 2 pi on n. And that n is, if I was to go 2 pi on a, that's going to give me a period of a. Is the period of this a? No, it's not. So the period of this is a means that a and b can instantly be ruled out. So that way, if you do something like that and you have to guess, you've only got to guess between one of three options. Now have a look at this graph. The graph over here, has it been moved to the left or to the right? Haven't we moved that to the... We've moved it to the left. It could be either. But think about where the asymptotes are. Okay? So think about where the asymptote is. So we've actually moved that graph to the left. So which one of these, and we've moved it to the left, what units? A on 2. So what's the answer? So I did it, and the answer's E. Yep. So the answer is E. If you know that graph straight away, it shouldn't take you that long. And look, you could, by the way, sketch it, but you're wasting your time. I really think you need to be able to do that. Now, remember how I talked about addition of ordinates yesterday? Well, with this one, think about the best way to do this is to use addition of ordinates. Now, let's have a look at this one. This can be a little bit tricky. X cubed on x is x squared plus a on x. Now, if we did addition of ordinates, what is the... Now, it says here a is greater than 0. A hyperbola graph, 1 over x, 2 over x, doesn't matter. Isn't a hyperbola graph going to look like this? So if I had that graph plus x squared, then I couldn't possibly have the graph on that side of the upper side of the asymptote. So I'm crossing that out using addition of ordinates. If I add this, if I add those two things in blue together, I'm going to have a graph which is underneath this line here. So therefore, it's clearly not A. Now, if I then have a look at the other one, x squared plus a on x, but this time a is less than 0, then I've got a coordinate something like this. If I added that together, then I reckon it could be that. But why isn't it that? If I have a look over here, look at so it could be for the first one, but if you have a look over here, if I subtract that ordinate away from x squared, then it's going to be under the graph, so it can't be that one either. The second one, if I've got the ordinate of 2x squared, 2x squared plus a on x squared, isn't the asymptote x squared on the graph? So how could we possibly get that? So we cross that out. So therefore it's out of D and E. Now if we have a look at D, it's going to be x squared plus a on x squared. Now what does the graph of a on x squared look like? And it says here for a is greater than 0, so we know that it's going to look something like this. So if I've got that plus the graph of x squared here, and if I'm adding those together, is it that one? Well, I think it is, just by having a look at that. If you tried the other one for a is less than 0, then you're going to, once again, addition of ordinates, it's going to be underneath that. So therefore, the most logical one is D. Those are not easy to go through. That might take you 2 minutes. But the other ones, since they should be taking you 30 seconds, that's where you make up, that's where you just have to spend more time on that one. Don't worry if it's taking you more than a minute and a half. Caleb? Why can't it be C? Here, and that is, for starters, it says here, the maximal domain and range. Well, what I'm going to do, first of all, is I'm going to do this to work out the domain first. 4x minus 1 has to be between 1 and minus 1. This is probably the easiest way. And just solve for x. If I add 1 to both sides, I've got 0, 4x, and 2. And then I divide both sides by 4. That's going to give me 0x and a half. And look at that. That rules out A, C, and D instantly. And in actual fact, it rules out A, C, and E, and then I need to work out which one of those it is. I then just plug into the range of negative pi on 2. We are then multiplying it by 3. So pi on 2 minus pi on 2 would become minus 3 pi on 2, and 3 pi on 2, and then what we need to do is we need to add pi on 2. So it'll be minus 3 pi on 2 plus pi on 2, which is minus pi to 2 pi. Okay, so then the answer is B. All right. Now, this one. What did I say about this one? With these, the first thing you're looking at is whether it depends on x and y. Now, can you see that the first two have x, the third one has y? As I go across in x values, is the gradients changing? So therefore, does it depend on y? It depends on x, but it doesn't depend on y. So therefore, these ones here are just there to throw you off. You can cross them off. Because as I go up in y values, what do you notice about all of these gradients? They're all the same. So it's not depending on y. Y is not changing that. So now what we do is we decide. Now the first thing I do is I usually look at quadrants, but I reckon the best thing to do is pick a value. Now can you see there that 0.25 pi? 0.25 pi approximately. That's going to give me, that's pi on 4, isn't it? Now let's sub in pi on 4 into those ones and see which one works. Now what gradient do you have here at pi on 4? 0, or pretty close to 0, don't you, according to the graph? You don't know for sure, but it looks pretty spot on. So therefore, if I throw pi on 4 in there, what is sine of pi on 2? 1. 2 times pi on 4 is pi on 2. So sine of pi on 2 is 1, so therefore that's going to be wrong. What is cos of pi on 2? 0. And what is cos of pi on 8? Not 0. So which one is it? The answer's B. Okay? And that's it, isn't it? All right. How do we feel about that? Zoom button now. So I'm recording. Shh. What you do is this says that z plus 1 is a linear factor, and you need to write that, ladies and gentlemen. Because then, now the thing is, if z plus 1 is a linear factor, you can go and divide and do division. That's fine. That's one method, and that might take you some time. But if z plus 1 is a linear factor, then I would factorise by inspection first. So I've got z plus 1 there. Now, if I've got z plus 1 and I've got a cubic, then, yeah, sorry, my bad. Then if I do that, then what you need to do is, let's have a look. We've got a z cubed. This is not going to work as well with maybe another coefficient. But I'm going to try z squared there. And you can see there that I've got to get to plus 20. So the only way I'm going to get a constant of 20 is if that's 20. So therefore, I'm just going to make up something. I'm going to make it called alpha z. What does alpha equal? Let's think about it. If I was to expand that out, I've got alpha 1 times alpha z is plus 20z is going to give me 28z. So therefore, what would the answer be? What's alpha going to be? 8. Alpha's going to be 8. Okay, and so I'd write that out. So alpha is equal to 8, just showing that you've sort of worked that out, and we've done it by inspection. So therefore, what we have is z cubed plus 9z squared plus 28z plus 20 is equal to z plus 1 z squared plus 8z plus 20. Now, what I would then do is I can't factorise the first one, the linear factor, that's fine. But what I can do is I can complete the square. So I'm going to do z plus 1, and I'm going to complete the square of that 8z squared, because we can't factorise it. So it's z. I'm going to do square brackets, z plus 4, all squared, minus 16 plus 20. Now, usually when you have a real numbers, then we would have to stop there, because we can't factorise using dots, because that is a number. That number there, z plus 1, what we've got is we've got z plus 4, if you like, plus 4 all squared. That's plus 4. But remember, there's the sum of perfect squares for complex numbers. So the sum of perfect squares means that 4 is the same as, isn't that minus 4i squared? Yeah? And then minus 4i squared, I can change that to dots. Okay? So dots is minus 2i plus 2i. So the answer is z plus 1. And then we change sops into dots. That's z plus 4 minus 2i. Z plus 4 plus 2i. And it says here, factorise that. So we've now factorised. That's our answer. Okay. Now, if you did it that method, you could honestly do that in a minute and a half, I would say, if you're really right up to it. Otherwise, the other method is you'd need to do the division of z plus 1 into z cubed plus 9z squared plus 28z. I'm not going to do it, but you can see there that you get z squared, and then you multiply it out, z cubed plus z squared, and then you'd have to do all of that, and then you get 8z squared. How many times does that go into that? It's a longer process, isn't it? So by doing this factorising by inspection first, definitely saved us a fair bit of time in the exam. Now for this one here, it's saying f of x is equal to arctan of 2x. Now I guess this is one of those ones where as long as you apply the chain rule in your head, you're going to be all right. But f dash of x is equal to... Now I sort of did it, I did it the long way just to make sure I'd get the answer right. I letting u equal 2x to u dx equals 2, and then applying that through. So then using the chain rule, what I would have got is 1 over 1 plus 4x squared for f dash of x. So you can do that. Now that's worth you 1 mark. Now then finding f double dash of x. Well, what I'm going to do is I'm going to actually, rather than use the quotient rule, it would make sense to me, depends on your preference, I'm going to let that be to the power of minus 1. Now, remember with the chain rule, we do the derivative of what's inside, we multiply it out the front. So f double dash of x is equal to 2 times the derivative of inside that bracket, which a lot of people forget. So do it the long way if you're forgetting this. 8x times, we're then getting the derivative and bringing it to the front, which is negative 1, and then we're dropping the power by 1. 4x squared to the power of negative 2. Sorry, 1 plus 4x squared. 1 plus 4x squared to the power of negative 2. Now what I'm going to do is when I multiply those out, that's going to give me minus 16x over 1 plus 4x squared to the power of 2. Now it's just saying to multiply through and find f double dash of pi on 2. So f double dash of pi on 2 is equal to minus 16 on pi on 2 is minus 8 pi over 1 plus 4 pi on 2 squared, which is pi squared on 4 squared. And that's going to cancel out to be minus 8 pi over 1 plus pi squared squared. That's your answer. Did you guys get that? Yeah. Good. All right. Now, that is now session. We've now done session 1, 2, 3, and 4. We're starting to bring all the things together. I'm going to stop there, and in the next lesson we're going to go over a fair few, session 5, 6, and probably 7.
5 and 6.
We're going to be looking. We're going to do a fair bit next session. I'm probably going to spend less time explaining.
Yep.
Okay. All right. So I'm going to stop there.